Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. My dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly let me know in the chats. Quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening guys, good evening and welcome back. Good evening and welcome back. Good evening and welcome back. I think I'm perfectly audible, visible to everyone, yeah? So people, as you all must be knowing, today it's going to be an amazing session wherein I'll be discussing your complete chemistry in just some 100 questions, right? And again, I'm repeating the same thing, that you can expect your questions directly, indirectly from this particular session as well, okay? Because all the questions which I have come up with in the today's session, they're all hand-picked questions. Whatever questions I feel would be coming in the NEET 2025 examination from the subject chemistry, I have come up with all of those questions in this particular session, okay? So quickly, let me know in the chats if all of you are perfectly able to hear me, if the audio video is completely fine. Just let me know quickly in the chats. Quickly, I want to know it in the chats. No, class duration will be just for 2 hours, okay? Maximum 2 hours I'll take. In 2 hours, I'll be finishing all these questions in detail, right? The duration is going to be just almost like 2 hours. Don't worry about that. And people, again, the PDF of this particular session I'll be sharing on my Telegram channel, right? If you're not the part of the Telegram channel yet, be the part of the Telegram channel as soon as possible. The name of the Telegram channel is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official is the name of the Telegram channel on which I shall be sharing the PDF of this particular session as well. Okay. All right. So all of you are ready? All of you are super ready, people? Should we start the session? Our Phoenix batch for 2026 aspirants will be starting after the NEET 2025. Let's complete the NEET 2025 first, then your Phoenix 2026 will be started. Don't worry. All ready with your pen and paper, guys? All ready with your pen and paper? People are asking how many marks can we expect from this particular session. I would say whatever questions will be asked in the NEET 2025 examination, directly, indirectly, you can expect the questions from this particular session. Okay? I think that is the answer of all of your questions. Okay? Perfect. So be ready with your pen and paper. Let's get going. Let's get started. So my dear students, the first question with which I shall be starting the session is from the chapter Electrochemistry. I hope you can easily look at the question on the basis of, if you look at the question carefully, on the basis of standard electrode potentials of the redox couples given below, find out which of the following is the strongest oxidizing agent. We have to check which of the following is the strongest oxidizing agent. My dear students, first of all, you should know oxidizing agent itself undergoes reduction. Oxidizing agent itself undergoes reduction. And let me tell you, the one that undergoes reduction easily, that will be the better oxidizing agent. The one that undergoes reduction easily, that will be the better oxidizing agent. Now, which one undergoes reduction easily? The one that has got more SRP value. The one that has got more SRP value, that undergoes reduction easily, that will be the better oxidizing agent. Now, my dear students, look at all these options. Look at all these options. If you look carefully, Fe plus 3 to plus 2. Plus 3 to plus 2 means decrease in the oxidation state. Decrease in the oxidation state means reduction. So this is the SRP value that's given. 0 to minus 1, again SRP. Plus 2 to 0, again SRP. Ag positive to Ag, again SRP. Now, which one do you see has got the maximum SRP value? Just compare all these values. Just compare all these values. I can say this is the maximum SRP value among all. This is the maximum SRP value among all, right? And maximum the SRP, better is going to be the oxidizing agent. So it's going to be Ag positive that is going to be the better oxidizing agent among all. I hope this particular question is very much clear to every one of you. Okay, expect this sort of a question in the examination paper. Moving on to the second question. A simple and basic question based on solubility product, right? Just check it out. Try to solve this question as well. My dear students, the solubility of CuBr is 2 into 10 raised power minus 4. The Ksp value for CuBr is, first of all, you should know how CuBr undergoes dissociation. Cu positive plus Br negative. This is how it is going to undergo dissociation. Now, my dear students, if its solubility is S, this is going to be S, this is going to be S. When you write the Ksp expression is going to be simply concentration of copper positive raised power stoichiometry coefficient, concentration of Br negative raised power stoichiometry coefficient. Perfect. As per the question, my dear students, as per the question, the concentration of Cu positive here is S, concentration of Br negative is also S, so it becomes S square, right? Now, as per the question, solubility of CuBr is given to us as 2 into 10 raised power minus 4. So it's 2 into 10 raised power minus 4 ka square. The value is going to be 4 into 10 raised power minus 8. Is there any option like this? Yes, 4 into 10 raised power minus 8 is going to be the correct answer of this particular question, right? A basic question which you can expect in the upcoming NEET examination as well. I believe it's clear to everyone. Yeah? Let me move on to one more question. My dear students, look at this particular question from the concept of Lee-Chatelier principle. Just check it out. N2 plus 3 times H2 gives 2 times NH3. The reaction is like this. N2 gas plus 3 times H2 gas, it gives 2 times NH3 gas. This is your reaction. Look carefully, my dear students. On reactant side, how many gaseous moles you have? 3 plus 1, 4. On product side, how many gaseous moles you have? You have got 2 moles, right? So, as per the question, on increasing the pressure, when we increase the pressure, reaction is going to shift in the direction of decreasing moles. On increasing the pressure, the reaction is going to shift into the direction of decreasing moles. In which direction moles are decreasing? In the forward direction, moles are decreasing. So, on increasing the pressure, the reaction is going to shift in the direction of decreasing moles, and moles are decreasing in the forward direction. So I would say the reaction is going to be shifting in the forward direction, right? A basic question which you must know. This is a simple concept which I'm using over here. When we increase the pressure, equilibrium will try to decrease it. How equilibrium will decrease the pressure? It will shift the reaction in such a direction in which the gaseous moles will be decreasing. Okay. Let's move on to one more question, my dear students. Moving on to one more question. A vessel of 1 liter capacity, containing 1 mole of SO3 is heated till a state of equilibrium is attained. At equilibrium, 0.6 moles of SO2 had formed. The value of equilibrium constant is, right? Again, a short question, my dear students, from the chapter equilibrium. So first of all, your reaction is 2 times SO3 gas. It is in equilibrium with what? It is in equilibrium with 2 times SO2 gas, and with this we have got O2 gas as well. My dear students, as per the question is concerned, we are starting with 1 mole of SO3. So in the beginning this will be 0, this will be 0. Now at equilibrium, let's assume that out of 1 mole of reactant, X moles got converted into product. So I'll be left with 1 minus X moles of reactant. So these are the moles of reactant left in the container at equilibrium. Now, my dear students, 2 moles gives us 2 moles, 1 mole gives us 1 mole, so X are going to give us X moles. Similarly, 2 moles gives us 1 mole, so 1 mole gives us 1 by 2 moles, X is going to give me X by 2 moles. So I got the moles of reactants and products in the container at equilibrium. Present in the container at equilibrium. Now, in the question, they are mentioning one more thing. At equilibrium, 0.6 moles of SO2 are formed. So number of moles of SO2 at equilibrium as per the question are given to me as 0.6. But we know number of moles of SO2 at equilibrium is nothing but X. So you technically got the value of X. Right? So 1 minus X, 1 minus 0.6 will be 0.4. X value is 0.6. x by 2, that means 0.6 divided by 2, that means 0.3. So these are the moles of reactants products present in the container at equilibrium. Now divide these moles by the total volume of the vessel, that's 1 liter. So what do you get? You got the concentrations of reactants products in the container at equilibrium. And since you got the concentrations, you can easily write the Kc expression. Kc expression is going to be concentration of SO2 at equilibrium raised power 2, concentration of O2 at equilibrium raised power 1 divided by concentration of SO3 at equilibrium raised power 2. All the values are given to us. Concentration of SO2 at equilibrium, that is 0.6 raised power 2. Concentration of O2 at equilibrium is 0.3 divided by concentration of SO3 at equilibrium, that is 0.4 ka square. You just need to solve this and you are done. You have calculated the value of Kc, which I was supposed to calculate as far as the question was concerned. I believe this particular question is clear, and my dear students, after solving, this particular answer will come out to be 0.68. Okay, I hope this particular question is clear to every one of you. Now, my dear students, look at this particular question. Which of the following 0.1 molar solution will show maximum boiling point? Which of the following will show maximum boiling point? What do you think about this particular one? What do you think about this particular one? Quickly in the chats. I'm looking at your chats only. What do you think? I'm looking at your chats only. Quick. Quick, people. Everyone. I can see a lot of students are already given the correct answer. Exactly. The question is based on the Van 't Hoff vector. So, my dear students, that particular substance which is going to give more ions in the solution, that particular substance which is going to give us more ions in the solution will have more boiling point, because you know your boiling point of the solution, that is directly proportional to Van 't Hoff vector in case of dissociation, and your Van 't Hoff vector is directly proportional to number of ions produced in the solution. Number of ions produced in the solution. Okay. Now, which one of the following will produce maximum ions? NaCl will dissociate as Na positive plus Cl negative, so it's just giving us 2 ions, right? Similarly, when it comes to your magnesium sulfate, MgSO4, it is going to dissociate into Mg di positive plus SO4 di negative, so just 2 ions. If you talk about chromium sulfate, Cr2SO4 whole thrice, how will it undergo dissociation? It will undergo dissociation as 2 times Cr tri positive plus 3 times SO4 di negative. So how many ions it's furnishing? It's giving us 5 ions. More the ions generated, more the Van 't Hoff vector, more is going to be the boiling point of the solution. So it has to be option D. That is going to be the correct answer of this particular question, people. Okay? I hope this is clear. Remember this expression, that's it. Remember the expression, that's it. All right. Moving on to one more. This is one of the questions which I believe every one of you would have solved at least once in the chapter mole concept. In which case, the number of molecules will be maximum. The number of molecules will be maximum. What do you think, my dear students? Quickly, let me know in the chats. First of all, you have got 18 ml water. 18 ml water means 18 grams of water. 18 ml water means 18 grams water. 18 grams water means 1 mole water. And in 1 mole water, there will be any molecules. There will be any molecules, right? Perfect. 0.18 grams of water. 0.18 grams of water. So given mass divided by molar mass. It will be 0.01 moles. So I got the moles, and moles multiplied by Avogadro's number gives me the molecules. So here you have got 0.01 Na molecules, right? 10 raised power minus 3 moles of water, right? So multiply these moles with the Avogadro's number. So you got the molecules. Now 0.00224 liters of water vapors at 1 atm and 273 Kelvin. So volume is given at STP. So divide with 22.4 liters, you'll be getting the moles. Multiply those moles with Avogadro's number, you'll be getting the answer. Now tell me, which of the following will have maximum? Which of the following will have maximum molecules? It is definitely going to be the first option, which will contain maximum number of molecules. I hope this particular question is again clear to every one of you. Okay. My dear students, look at this one. Look at this one. Look at this one. The energy of the second Bohr's orbit of hydrogen atom is 328 kilojoules per mole. Hence, the energy of the fourth Bohr's orbit would be. So, N1 value is 2, N1 value is 2, N2 value is 4. So, my dear students, this particular expression, I believe all of you would be knowing. E1 divided by E2 is equal to N2 square divided by N1 square, right? N2 square divided by N1 square. Because you know, energy of the nth Bohr's orbit is equal to minus 13.6 Z square by N square. So basically, when you talk about energy, that's inversely proportional to n square. That is the reason why I wrote this particular expression. Now, people, E1 value is given to me as per the question as 328. I need to calculate E2 is equal to N2 square. N2 square means 4 ka square is 16. N1 square, 2 ka square is 4. So from this particular expression, you can get the E2 value, which will come out to be 328 multiplied by 4 divided by 16. So 4, 1, 4, 4, it will be 4, 8, 32, 4, 2, 8, 82 kilojoules per mole. Is there any option like that with a negative sign? So it's option 2. That is going to be the correct answer of this particular question. Okay. Now, my dear students, what do you think about the answer of this question? The IUPAC name of this particular one, A3CO C2O4 thrice is. What would be its IUPAC name? What do you think about this one? So first of all, it is potassium. It is potassium. Okay. It is potassium. Then it's going to be trioxylato. Then it's going to be trioxylato. Potassium trioxylato. Okay. My dear students, then it's going to be cobaltate. Then it's going to be cobaltate. Oxidation state of cobalt here will be 3. Right? So potassium trioxylato, cobaltate 3 is going to be the name of this particular compound. Look at the options. Potassium trioxylato, cobaltate 3. That means option 4 is the one that has to be the correct answer of this particular question. All right. Moving on to the next one, my dear students. Moving on to the next one. Moving on to the next one. Moving on to the next one. Look at this one. Again, the question based on equilibrium only. And it's a simple question. If you got to know how to solve the last question of equilibrium, you can easily solve this one as well. My dear students, reaction as per the question is given to us as H2 plus I2 gives 2 times HI. This is the reaction. Now, initially, as per the question, we are starting with 4.5 moles each of reactants, okay, in a 10-liter vessel. At equilibrium, number of moles of HI. Number of moles of HI formed at equilibrium is how much? 3. Perfect. What do I need to calculate? I need to get the value of Kc. I need to get the value of Kc. Now, how you are going to approach to this particular question? It's again a simple one. My dear students, at equilibrium, there will be 4.5 minus X moles of H2. There will be 4.5 minus X moles of I2. Now, 1 mole gives 2 moles. X would have given 2X moles. So, these are the moles of reactants products present in the container at equilibrium. Now, you know, number of moles of HI at equilibrium, that is equal to 2X. So, 2X value is equal to 3. So, X value would be equal to 1.5. So, 4.5 minus 1.5 will be 3. 4.5 minus 1.5 will be 3. 2 into X is equal to 3. Perfect. So you got the moles of reactants products in the container at equilibrium. Now I'm dividing these moles with the total volume of the vessel, which is how much? 10 liters, right? So what do I call these terms as? These are the concentrations. These are the concentrations of reactants products in the container at equilibrium. Since you got the concentrations, you can easily write the expression of Kc. It is going to be concentration of HI at equilibrium, which is 3 by 10, raised power stoichiometry coefficient, that's 2, whole divided by. Concentration of H2 at equilibrium, that's 3 by 10. Raised power stoichiometry coefficient, that's 1. Concentration of I2 at equilibrium, it's again 3 by 10. Raised power stoichiometry coefficient, that's 1. When you solve this, the value exactly comes out to be 1. So I can say your equilibrium constant of the reaction is nothing but, that is 1. Okay? That is 1. Perfect. Perfect, guys. Perfect. All right. Let's have a look on one more question. This is a frequently asked question, guys. Many a times the same question. I have solved the question in a lot of sessions. I've repeated the question again in this particular session as well. But I want you guys to give this particular question a try. I want you guys to give this particular question a try. It's a simple basic question when it comes to your first order kinetics. My dear students, imagine that your reaction is A gives B. Imagine that your reaction is A gives B. Rate constant of the reaction is given to me as 10 raised power minus 2 second inverse. This is the rate constant of the reaction. Now, initially at time t is equal to 0, the amount of reactant, which I'm representing with A naught, that's equal to 20 grams. Perfect. Now, how long will it take? How long will it take for the amount of reactant to reduce from 20 grams to 5 grams? From 20 grams to 5 grams. Perfect. So, this is the value of 80. Perfect. A basic question wherein you just need to use the integrated rate equation and you're done with the question. My dear students, the equation will be T is equal to 2.303 divided by K. It's log of A naught divided by AT. Now, it is just a matter of calculation. Nothing else. K value is given. A naught value is given, AT value is given. Put the values in the expression and kill it. 2.303 divided by, it is 10 raised power minus 2 log of, what is A naught? A naught is 20, AT is 5, 5, 1, 5, 4. Log of 4 is nothing but 0.6. Now matter of calculation. So it is 2.303 multiplied by 0.6 multiplied by, take this 10 raised power minus 2 up as 10 raised power 2. So this answer is going to come in seconds. Yes. And if you look at the exact answer is going to be 138 seconds, people. I believe this particular question is again super clear to every one of you. Yeah. Perfect. Amazing, guys. Moving on to one more question. Look at this one. Look at this one. I feel from this particular table question will be asked. There will be a question based on the table. I strongly feel that. Let's have a look. How do we solve the question when the table is given to us? First of all, for a chemical reaction, A plus B gives product. You are given the reaction A plus B gives product. In the question, they have mentioned that the order is 1 with respect to A and the order is 1 with respect to B. So how do I first of all write the rate law? R is equal to K. Concentration of A raised power 1, concentration of B raised power 1. Okay. If I put the experiment number 1 details into this expression, what do I get? R value here is 0.1 is equal to K. Concentration of A is 20 raised power 1. Concentration of B is 0.5 raised power 1. So this is my equation number 1. Now let's make equation number 2. R is equal to 0.4 is equal to K. Concentration of A is X raised power 1. Concentration of B is 0.5 raised power 1. This is equation number 2. Similarly, 0.8 is equal to K. 40 raised power 1 and Y raised power 1. This is equation number 3. So how many equations I got? I got 3 equations. My dear students, if I do one thing, I'm dividing equation 2 with equation 1. When I divide equation 2 with equation 1, 0.4 divided by 0.1 will be 4 is equal. K and K gets cancelled, 0.5 cancelled. This will be X divided by 20. So X by 20 is equal to 4, which tells you that X is equal to 80. So you got the value of X as 80. Perfect. Simple. We are done. The value of X is coming out to be 80. Now, similarly, you can solve the other 2 equations and get the value of Y. You can divide the other 2 equations, get the value of Y. And my dear students, the final answer is nothing but it is 80 and 2 respectively. Yes, the level of the examination is going to be similar, guys. So whatever questions I'm solving right now, expect the same level of the questions in your upcoming NEET examination for sure. Okay, don't worry about it. Just don't be tensed. Okay? There are 23 lakh students who are going to write the examination. Okay? Do not think about the results. Do not think about the consequences. What is going to happen? What will happen if this happens, if that happens? Please avoid that. Avoid those thoughts at this particular point of time. Just try to revise as much as possible. Try to revise your formula sheets, your organic reaction sheets, your short notes. That's the only concern which you should have at this point of time. If you keep on thinking what will happen, what will be the consequences, my dear students, you'll be disturbed and it will eventually affect your NEET examination as well. So do not do that. Okay? Do not do that, please. It's a request. Okay, moving on to one more. Have a look on this particular question, guys. Have a look on this particular question. When an electron is excited from ground level to 5th orbit, so N1 value is 5. Sorry, ground level means 1 and N2 is 5. N2 is 5. The number of spectral lines obtained. How do you calculate the spectral lines? Simple. I have to given you this formula many times. N2 minus N1. N2 minus N1 plus 1 divided by 2. So N2 is nothing but 5. So 5 minus 1 multiplied by 5 minus 1 plus 1 divided by 2. So 5 minus 1 is 4. 4 5s are 20. 20 divided by 2 is 10. So there are in total 10 spectral lines which will be observed. Okay. Again, a simple question which all of you can easily solve, I believe. Enthalpy of formation of CCl4, water, CO2 and HCl are given. The magnitude of enthalpy of reaction. My dear students, how do you calculate enthalpy of reaction? How do you calculate enthalpy of reaction from the enthalpies of formations? You should know enthalpy of reaction is nothing but enthalpy of formation of products minus enthalpy of formation of reactants. Enthalpy of reaction is nothing but enthalpy of formation of products minus enthalpy of formation of reactants. So start with this product. The coefficient here is 1, so it's 1 multiplied by enthalpy of formation of carbon dioxide plus it is 4 multiplied by enthalpy of formation of your HCl. So this is the enthalpy of formation of products minus what is the enthalpy of formation of reactants? It is 1 multiplied by enthalpy of formation of your CCl4 plus 2 multiplied by enthalpy of formation of your water. Perfect. Right? Now, my dear students, as per the question, all these parameters are given. All these values are given to me in the question. Put the values and get the answer. All these values, as you can see, all these values are given to us. Put the values, get the answer. That's all. You just were supposed to make the equation. You made the equation and you're sorted. You made the equation and you're sorted. And when you talk about its final answer, when you put all the values here, the final answer is going to be minus 173 kilojoules per mole. Right? Perfect. Amazing, guys. I'm moving on to one more question. This is again a frequently asked question. I've solved this question in the last session as well, but I again wanted to solve this question in this session as well because expect a question from extensive intensive properties for sure. For sure, my dear students. And it's a simple question, you know it. The total number of intensive properties. So, first of all, when it comes to volume, volume is the example of extensive property. Molar heat capacity is the example of intensive property. Molarity means concentration, intensive property. Inert cell, intensive property. Gives free energy, extensive property. What do you have? Molar mass is the intensive property. Perfect. Mole is the extensive property. So, the total number of intensive properties. How many intensive properties are there? 1, 2, 3, and 4. There are in total 4 intensive properties which I can see. Okay? There are in total 4 intensive properties which I can see. So first of all, what are intensive properties? Whose value does not change on changing the size of the system. When you change the size of the system, those properties whose values does not change on changing the size of the system, you call them as the intensive properties. So it's option 4. That is going to be the correct answer of this question as well. Now, my dear students, ionic radius. These are all your isoelectronic species. And you know, when you talk about the size of the isoelectronic species, it's directly proportional to negative charge, inversely proportional to positive charge. Simple. More the negative, more the size. More the negative charge, more the size. Right? More the negative charge, more the size. Now, what do you think is going to be the correct one? More the negative charge, more the size. More the negative charge, more the size. So, minus 2, minus 1, plus 1, plus 2. More the negative charge, more the size. So, it has to be option C. That has to be the correct one. Just remember this particular one and you are done. And expect a question from this as well, for sure. For sure, my dear students. Okay? All right. The species having maximum number of lone pair of electrons on the central atom. So first of all, I'll show you one species. Talk about this I3 negative. I'll show you how to calculate the lone pairs on the central atom and eventually you'll be able to solve the question. You have got I3 negative. My dear students, I3 negative I can write as I2 negative. Correct? I3 negative I can write like this. I2 negative. First of all, how many valence electrons iodine has? 7 valence electrons. There is a negative charge. So 7 plus 1 makes it 8. How many surrounding atoms? 2. 2 surrounding atoms means 2 sigma bonds. So out of 8 valence electrons, 2 valence electrons are used to form 2 sigma bonds. So there are 6 electrons left as such in the form of 3 lone pairs. So there are in total 3 lone pairs on this central iodine. Okay. Similarly, my dear students, when you check the lone pairs on this sulfur, it will be 1. When you check the lone pairs on this xenon, it will be 2. Perfect. Right? Same goes for your ClO3 negative. You can easily check. Perfect. There will be 1 lone pair on chlorine. So where do you see maximum lone pairs on the central atom? It's going to be the last option. Right? Questions have been asked from this and questions will be asked from this too. All right. Look at this one. The molar solubility of CaF2. The molar solubility of CaF2 in 0.1 molar solution of NaF. So first of all, CaF2, how will it undergo dissociation? Calcium di positive plus 2 times F negative. Correct? Let's say its solubility is S. This will be S. This will be 2S. Now, my dear students, we have to calculate solubility of CaF2. We have to calculate solubility of CaF2 in what? In NaF. How NaF would have undergone dissociation? Na positive plus F negative. So tell me one thing. What was the concentration of NaF? It was 0.1 molar. This would be 0. This would be 0 in the beginning. Now this would be 0. This would be 0.1. This would be 0.1. So my dear students, in the same container, do you see F negative here also, F negative here also. So what will be the total F negative concentration? It is 2S plus 0.1, right? And due to the common ion effect, solubility would have reduced, so it will be finally 0.1 molar. It will be finally 0.1 molar. Now just do one thing, write the expression of KSP. Expression of KSP is going to be concentration of calcium dipole, so that's S raised power 1 multiplied by concentration of F negative, that is 0.1 raised power stoichiometric coefficient, that's 2. Perfect. Now people, as per the equation, KSP value is given to me as 5.3 into 10 raised power minus 11 is equal to S multiplied by 10 raised power minus 2. So S value here comes out to be 5.3 into 10 raised power minus 9 moles per liter, right? Do you see any option like this? Yes, I can see option 4. That is going to be the correct answer of the question. Perfect, right? A simple question, guys, but a good one. And these sort of questions have been asked in NEET from very long time. Expect again this sort of a question in the upcoming examination. Let's move on to one more. Magnetic moment is 2.84 Bohr magnetrons. Magnetic moment is 2.84 Bohr magnetrons. Okay. Now, which one of the following has got the magnetic moment of 2.84? First of all, magnetic moment, how do you calculate? Root of n into n plus 2 Bohr magnetrons, where n represents your number of unpaired electrons. N represents number of unpaired electrons. When can the value come out to be 2.84? When can the value come out to be 2.84? The value can only come out to be 2.84 if n value is 2. 2 plus 2, 4. 4 2s are 8. Root of 8 is 2.84. So there should be 2 unpaired electrons present. Now, which of the following has got 2 unpaired electrons present? It's nickel dye positive. Outermost configuration of nickel, iron, cobalt, nickel. So it is 3d8 is 2 basically. But it's nickel dye positive. So take 2 electrons out. Take 2 electrons out. It is 3d8 configuration. And when you talk about this 3d8 configuration, 1, 2, 3, 4, 5, 6, 7, 8. So this is 3d8 configuration. There are 2 unpaired electrons, right? So it's absolutely going to be the last one. That has to be the correct answer of this particular question. Right, people? Basic one this was again, but the easier one. Well, this is something which I believe it should be on the tip of your tongue. What is it? The electronic configuration of copper, right? You should know it. You should know it. Electronic configuration of copper. You should know it, guys. Quick. Done? I want everyone to say it, guys. Don't make the session boring. Just give me a second. Just a second, guys. Okay, I think you're done. The electronic configuration of copper. Copper is 3d10, 4s1, right? 3d10, 4s1. Where is it? Here. Okay, moving on to one more. Tell me the answer of this one. Tell me the answer of this one. Tell me the answer of this one. This is again a very simple one, and I believe you can easily check it out. Quick. Quick, guys. Done? Absolutely, all of you are perfectly right. It's hexacyanidoferrate 3. Amazing. All right. What about this one? The geometry and magnetic behavior of the complex NiCO4. The geometry and magnetic behavior of the complex NiCO4. So first of all, if you talk about this nickel here is in zero oxidation state. Outermost configuration of nickel is going to be 3d8, 4s2, 4p0, 4d0, right? Perfect. Now, first of all, if you talk about this 3d8 configuration, 1, 2, 3, 4, 5, 6, 7, 8. Then you have got 4s carrying 2 electrons, you have got 4p carrying 0 and 4d carrying 0, right? Now, first of all, there are coordination number is 4. If coordination number is 4, that means, okay, leave coordination number aside. First of all, check it out. Is it a weak field ligand or a strong field ligand? It's a strong field ligand. If it is a strong field ligand, it's going to cause pairing of electrons. So one of the electron will shift here, one of the electron will shift here. So after pairing, there'll be this orbital vacant, there'll be these 3 orbitals vacant. Coordination number is 4. That means the central metal atom has to arrange 4 vacant orbitals for hybridization, and those are going to be sp3, right? It's going to be sp3. Perfect. Is there any unpaired electron? There is no unpaired electron because pairing has been done. So it is going to be diamagnetic. Perfect. So what is the answer of this question? sp3 means tetrahedral, and at the same time it's diamagnetic. At the same time it is diamagnetic. sp3 means tetrahedral, at the same time it is diamagnetic. So it has to be option B, my dear students. That is going to be the correct answer of this particular question. Now look at this one. Look at this one. Look at this one. Quickly in the chats. Done? This I have told you many a times. When it comes to the first order reactions, time taken to complete 75% of the first order reaction is equal to 2 times the half-life. Time taken to complete 87.5% of the first order reaction is equal to 3 times the half-life. Time taken to complete 99.9% of the first order reaction is equal to 10 times the half-life. Now, you were supposed to check this one. So I would say the value of x here is 3, right? So it has to be option 1. That is going to be the correct answer of the question. I hope I'm clear with this. Tell me the answer of this one. Tell me the answer of this one, guys. This is again a simple one, and I believe you can easily check it. Quickly, guys. First of all, on moving from left to right, you know ionization energy increases, right? You know ionization energy increases. But when it comes to beryllium and boron, beryllium has got more ionization energy than that of boron. Similarly, nitrogen has got more than that of oxygen. That's why these two interchange, and similarly, these two interchange. What is the logic? Nitrogen has got the half-filled configuration, and beryllium has got the stable configuration. So to take electron out from beryllium or nitrogen, more energy is required. That's the reason why their first ionization energies are more. Okay? Perfect. I hope this is also clear to everyone. Okay, what about this one, guys? Well, this is the asked question. This is the asked question. Why I came up with this? Because questions are frequently asked when it comes to your empirical molecular formula. So this you can easily solve, I believe. So as per the question, we are given with an organic compound containing carbon and hydrogen, right? The mass percentage of carbon. The mass percentage of carbon is given to me as 78%. That means 22% will be for hydrogen. Perfect. What am I supposed to calculate? Empirical formula, correct? My dear students, it is pretty much simple. The first point is to get the atomic ratio. Atomic ratio means given mass percentage divided by respect to atomic mass. Similarly, 22 divided by its atomic mass. Perfect. How much these values come out to be? Let's check it out. 78 by 12 comes out to be 6.5. 22 divided by 1 is equal to 22. Perfect. Now, Which one is the least number among the two? 6.5. Divide both the numbers by the least number. So you got approximately 1:3 as the simplest whole number ratio. If 1:3 is the simplest whole number ratio, that means the empirical formula is going to be CH3. Perfect. It's a simple, clear-cut question, and these sort of questions are asked frequently. Okay. Now, guys, look at this one. Look at this one. Well, I do not want you guys to solve this question from the starting till the end. I want you to look at the options, guess the options, and try to solve the question. If you look carefully, my dear students, water here, it's a weak field ligand. Cyanide here is a strong field ligand. This is not going to cause any sort of pairing. This will cause the pairing of electrons. This will not cause. This will cause. If this is not going to cause the pairing of electrons, then it will have high spin. It will have high spin moment. Okay? This will have comparatively low spin moment. The first one has got high spin moment, second one has got low spin moment, right? First one has got high, second one has got low. The first one should be high, second one should be low. So option 4 has to be the answer of the question. That's all. That's all. Okay? That's all. All right. What about this one? Orbital having 3 angular nodes and 3 total nodes. Let me give you the formula if you have forgotten. Total number of nodes is given by the formula n-1. This formula is used for total number of nodes. And in order to calculate angular nodes, when you talk about angular nodes are given by the value of L, and your radial or spherical nodes are given by the formula n minus L minus 1. Okay? Perfect. Now, check it out and tell me the answer. Orbital having 3 angular nodes and 3 total nodes. 3 total nodes. Quickly. 3 total nodes. Total nodes 3. That means n minus 1 is equal to 3. N minus 1 is equal to 3. That means n is equal to 4. Right? There's only one option which says that the principal quantum number is 4. That is this one, and we are done. Correct? Correct, people? Okay, one question. This is the asked question, guys, but still I came up with this one because you should, it's a very important reaction, you know it. The reaction which I'm talking about right now, it's a very important reaction. Quickly. Which of the following is the electrophile? Dichlorocarbene, electrophile. Tell me, where do we see this as the electrophile? In which reaction? In which reaction we see this as the electrophile? I want to know the name of the reaction. I want to know the name of the reaction. I want to know the name of the reaction. Exactly. Riemann-Tiemann reaction is the one wherein your dichlorocarbene is going to be your electrophile. Okay? Remember that. That can be also asked. Tell me the order of the stability of these resonating structures. Tell me the order of the stability of these resonating structures. My dear students, in order to check the stability, do you see any resonating structure wherein the atoms do not carry any charge? That is the first one. The first resonating structure wherein the atoms do not carry any charge. So A is maximum stable. A is maximum stable. Now talk about B and C. Talk about B and C. Count the bonds. 1, 2, 3, 4, 5, 6. 6 bonds. 1, 2, 3, 4, 5, 6. 6 bonds. Bonds are same. Bonds are same. So I cannot decide on the basis of bonds. Then what do I decide with? See, oxygen is carrying negative here. Oxygen is carrying negative here. Perfect. Oxygen is carrying positive here. Nitrogen is carrying positive here. Right? Positive charge is more stable on less electronegative element. Positive charge is more stable on less electronegative element. So C has to be more stable than that of B. So A, C, B is the order. Perfect? Yes. Which of the following molecules is least resonance stabilized? Which of the following molecule is least resonance stabilized? I want you guys to let me know its answer quickly. My dear students, if you see 2, 4, 6, 6 pi electrons are involved here in the complete cyclic conjugation, it's aromatic. 2, 4, 6, 6 pi electrons involved in the complete cyclic conjugation, aromatic. 2, 4, 6, 6 pi electrons involved in the complete cyclic conjugation, aromatic. If you talk about this particular carbon, this carbon is sp3 hybridized. So this is non-planar. Non-planar means non-aromatic, right? So which of the following is less stable? You know, aromatic ones are maximum stable, followed by non-aromatic ones, followed by anti-aromatic ones, right? So option D is the one which is comparatively less stable among all. Okay, comparatively less stable among all. What is the order of the stability of these structures? Tell me the order of the stability over here. First of all, is there any one wherein the atoms do not carry any charge? Yes, atoms do not carry any charge here. So 1 is maximum stable. Now among 2 and 3, nitrogen carrying positive, nitrogen carrying positive, carbon carrying negative, carbon carrying negative. So same charge is on same atoms. Same charge on same atoms. Now, more the distance between unlike charges, lesser the stability. So 2 will be more stable than that of 3. So 1, 2, 3 has to be the order. Okay, perfect. Simple basic question. Expect them. Tell me the answer of this one. Tell me the answer of this question. What is the question? Compare the bond lengths. 1, 2, 3, 4. Compare the bond lengths, my dear students. A good one this is. Compare the bond lengths. Here you have got a single bond, pure single bond. Here you have got a pure double bond. Now nitrogen has got the lone pair. It will show resonance. Right? Due to which you get partial double bond here. Here also you get partial double bond. This is pure single, pure double. Okay? Pure single, pure double. I'll say 2 will have minimum bond length, 1 will have maximum bond length. 2 will have minimum bond length, 1 will have maximum bond length. Because this is pure double, this is pure single. Now, here you got partial double, here you got partial double. Now, if you see in this particular case, more is the resonance because pi, sigma, lone pair, right? Here you have got pi, sigma, lone pair. Here resonance is more. Due to more resonance, there will be more double bond character. More double bond character means lesser bond length. So 4 bond length will be less than that of 3. So this is the bond length order. Right? This is the bond length order. Perfect, people. A simple basic question, a conceptual one. I believe you would have killed it. Arrange the compounds in the order of their decreasing acidic strength. Tell me in the chats. Decreasing acidic strength. So first of all, your reference is same everywhere. From where hydrogen is going to leave as H positive. Right? Perfect. Now, my dear students, when it comes to acidic strength is directly proportional to minus M showing groups, then minus H, minus I, plus H, plus M. This is the order. My dear students. So first of all, this CH3 will be showing plus H, right? NO2 minus M, OCH3 plus M, and this Cl, it is going to show, it's going to be withdrawing only. It's going to be withdrawing. Basically, it shows minus I as well as plus M. But over here, its withdrawing nature dominates. So first of all, minus M. Which one is minus 1? Minus M third. Third one is minus M showing. So third one is maximum acidic. So it has to be option C. That has to be the correct answer of this question as well. All right. Perfect, guys. Perfect. Amazing. Moving on to one more. Arrange the compounds in the order of decreasing acidic strength. Again, a similar question. So tell me its answer. You might do a mistake here. I feel so. Quick, guys. I want to know your answers first. Quick. Guys, it's pretty much simple. If you see, this is phenol, this is phenol. This is carboxylic acid, this is carboxylic acid. You know, carboxylic acids are stronger acids than phenols. Right? So, first of all, 3 and 4 will be more acidic than 1 and 2. Now, among 3 and 4, this is plus H showing, right? So, plus H showing, it decreases. It decreases acidic strength. So, third is going to be maximum acidic. Followed by fourth. Third is going to be maximum acidic, followed by fourth, right? Now, among 1 and 2, 2 is going to be more acidic than 1, right? So, it has to be option A. That has to be the correct answer of this particular question. Okay? I believe this is clear to everyone. And if it is clear, tell me the answer of this question. Guys. Which of the following acids have the lowest pKa? Lowest pKa value means more Ka value. More Ka value means more acidic strength. Basically, you have to check where is the acidic strength maximum. Where is the acidic strength maximum? 1 chlorine. 1 chlorine. 3 chlorine atoms. 2 chlorine atoms. More withdrawing groups, more acidic. So it has to be option C, which has to be the correct answer of this question. Which of the following compounds has the most acidic nature? Which of the following is most acidic? Tell me in the chats. Tell me in the chats, my dear students. So first of all, if you look at all these options, I can just have a look on option number B. Why is that? Because when it donates hydrogen as H positive, there will be a negative charge on this oxygen. So the conjugate base is resonance stabilized. Conjugate base is resonance stabilized. And wherever conjugate base is resonance stabilized, the acid is going to be definitely stronger. Right? So it has to be option B. Perfect. Well, I'll come up with the asked question. This is the asked question. But this is going to help out a lot. You can expect a similar sort of question in the upcoming exam as well. So tell me its answer. Tell me its answer, people. Everyone. Tell me its answer. Consider the following compounds, the number of compounds which obey Huckel's rule. Which obey Huckel's rule. Wherein there are 4 and plus 2 pi electrons. So 2, 4, 6, 8, 10. 10 pi electrons, obeying Huckel's rule. 2, 4, 6, 6 pi electron, obeying Huckel's rule. 4 pi electrons, not obeying. 4 pi, no. 2 pi, yes. 1, 2, 2, 4, 6, 8, 10, 12, 14. So how many are there? How many are there? How many are there? What about this one? You know, this one is non-aromatic. I hope you know that because it has got the tub-like structure. Anyways, there are 4 structures among these. There are 4 structures among these which are following the Huckel's rule. So option 4 has to be the correct answer of the question. Okay. Again, one more question, right, which has been asked, but deliberately I've come with this one so that your concept gets a little more clear here. Which of the following among the following is non-aromatic? Which one is non-aromatic? For the compound to be non-aromatic, it has to be non-planar, right? If you look at this particular carbon, it's sp3 hybridized. sp3 hybridized means non-planar. Non-planar means non-aromatic. Non-planar means non-aromatic. Okay. Similarly, my dear students, one more question. Now, you should be in a position to answer this one as well. You should be in a position to answer this question as well. I want to know. I want to know in the chats. I want to know in the chats, guys. Quick. Done? Okay, among the following the aromatic compounds are. Which of the following are aromatic? Quickly. Quickly, guys. It's a simple question based on all the things which we have discussed till now. Right? Based on all the things which we have discussed till now. Tell me the answer of this one. Tell me the answer of this one. Quick. Just give me a second, okay? Hello? I'm in a class right now. Yeah. Quick. Done? Stability. Quick. Stability. Guys, it's a simple question. It is a simple question. Tell me the answer quickly. Stability of carbocations. Quick. I can see majority coming up with the correct answer. Amazing. Absolutely, it has to be option 1. That has to be the correct answer. Good job. That means you know the concepts. Amazing. It's not option 1. What are you saying? Option C it is. It is option C. Why you are coming with option 1? It has to be option C. It has to be option C. Okay, not 1. Don't just look at option A that you saw third option here and you gave this as the answer. There is also one option wherein it is saying that 3 is more stable. So it has to be 3. Okay, what about this one? What about this one, guys? What about this one? For the first order reaction, choose the value of half-life. So first of all, I'm assuming this is the first order reaction, and for the first order reaction, half-life is 0.693 divided by K. 0.693 divided by K, right? Now, my dear students, one thing. The graph is between log 80 versus T. And the slope of this particular graph, you must be knowing minus K upon 2.303. That is the slope, minus K upon 2.303. Now, I can say slope is nothing but tan of theta, tan of 135. Tan of 135 is minus 1. Minus 1 is equal to minus K divided by 2.303. So K is equal to 2.303. So you got the value of K. So it is 0.693 divided by 2.303. Right? How much this comes out to be? I think 0.3. The half-life of the reaction is nothing but 0.3. Okay? Perfect. Okay, one memory-based question. One memory-based question which I believe everyone is going to easily solve. So what do you think about this one? What do you think about this one? Quick. Quick. This question I've shown you in the last session as well. Gadolinium. 4F7, right? Gadolinium, 4F7. Yeah, 4F7. One simple question. Which one among the following is the correct option? This question I have given you in that particular video also. How to guess the options. How to guess the options, right? I've given you this question there also in that particular video. For which of the following is correct for the right relationship between Cp and Cv for 1 mole of ideal gas? Cp minus Cv is equal to R, right? Cp minus Cv is equal to R. Simple question. A gas is allowed to expand in a well-insulated container. Well-insulated container against a constant external pressure of 2.5 atm. From the initial volume of 2.5 liters to final volume of this, the change in internal energy delta U will be. You know your delta U is nothing but that's equal to Q plus W. But it's well insulated, so Q is equal to 0. So delta U has to be equal to W. What is W? W is minus P external delta V, right? So minus, what is P external? P external is 2.5 atm. Delta V, change in volume. Change in volume is final minus initial. The value comes out to be 2. The value is going to be minus 5 atm liter. But I need not the answer in atm liter. I need the answer in joules. 1 atm liter is nothing but 101.3. So it's almost 505 joules. Almost 505 joules with the negative sign. Okay? A simple basic question from the chapter Thermodynamics. Yeah? Okay. This is just the formula. Just the formula to calculate entropy change in case of ideal gas. Entropy change in ideal gas. Quick. Entropy change in the ideal gas. What is the answer? It's a formula. It's a formula. I've got nothing to do with this. It's a formula. Quickly. It's a formula. Guys, you should remember this. Entropy change when the ideal gas undergoes expansion or compression. You should know it. Absolute is option 2. NR ln P initial by P final. NR ln P initial by P final. One more question. Look at it carefully. Look at it carefully. For the reaction, delta H is given, delta S is given. right? We have to calculate temperature at which the reaction will be spontaneous. For the reaction to be spontaneous, delta G has to be negative. So delta H minus T delta S, it has to be negative. What does that mean? That means delta H has to be less than T delta S. Or I can say T delta S has to be greater than delta H. Or I can say temperature has to be greater than delta H divided by delta S. So delta H is given to me as 35.5 kilojoules. So multiply it with 10 raised power 3 so that it comes in joules, divided by delta S is 83.6, right? Just solve this. I think this value will come out to be approximately 425. Perfect. So temperature has to be greater than 425 Kelvin, then only the reaction is going to be spontaneous. Temperature has to be greater than 425 Kelvin, then only the reaction has to be spontaneous. Okay. Perfect, guys. Perfect, perfect, perfect. What do you think about this question? Check it out. What do you think about this particular question? The correct thermodynamic condition for the spontaneous process. For the process to be spontaneous, delta G has to be negative. Delta G means delta H minus T delta S. This has to be negative. When can this particular term be always negative? If delta H is negative, delta S is positive. If delta H is negative, delta S is positive. That means this overall term will be always coming out to be negative. That means the reaction will be always spontaneous. So delta H has to be negative and delta S has to be positive. Delta H has to be negative, delta S has to be positive. Right? Simple basic question again this was, which easily solved. Look at the next one. Look at the next one, guys. The correct option for the free expansion. Free expansion means work done 0. Okay. Of an ideal gas under adiabatic condition. Adiabatic means Q is 0. W is 0, Q is 0. Delta U is equal to Q plus W. If Q is 0, W is 0, that means delta U is also 0. Delta U 0 means NCV delta T is 0, which tells you that delta T has to be 0. Now find your options. Find your options. Find your options, guys. Q0, delta T0, W0, everything 0. So what is it? It has to be option D. It has to be the correct answer of the question. It has to be the correct answer of the question. In which of the following equilibrium Kc and Kp are not equal? Well, you should know Kp is equal to Kc RT raised by delta Ng, right? Kp and Kc are not equal. So first of all, if delta Ng is 0, then Kp, Kc are equal. So if delta Ng would be non-zero, then only I can say Kp, Kc would not be equal. So which of the following reactions delta Ng is not equal to 0? It is option D. Because when you calculate delta Ng for this option number D, it is going to be number of moles of gaseous products, that's 2, minus number of moles of gaseous reactant, that's 1. So delta Ng is 1, which is non-zero. And if delta Ng is non-zero, Kp and Kc won't be equal. Okay? Kp, Kc won't be equal. Won't be equal. A basic question that is definitely going to boost up your confidence. Tell me its answer. Dipole moment is minimum in. Do you remember BF3? BF3 is a molecule of the type AB3L0, and all the molecules of the type AB3L0, their dipole moments are 0. Their dipole moments are 0. Okay. Well, this is the question which I have solved in the last session as well. I think you can easily solve this. This is 7 plus half of pKa minus pKb. 7 plus half of 3. This is the salt of, it's a salt of weak acid and weak base. So when the salt of weak acid and weak base undergoes hydrolysis, how do we calculate its pH? It is 7 plus half of pKa minus pKb. In the equation, pKa, pKb values are given. Put it here and get the answer. That's all. Okay. What about this one? Which pair of the molecules does not have identical structures? Which pair of structures does not have identical structures? What do you think? Which pair of molecules does not have identical structures? Quick. Quick, quick, quick. Absolutely, it's option 3. If you talk about BF3 is of the type AB3L0. ICL3 is of the type AB3L2. AB3L2, right? If the type is different, that means their geometries won't be different. I mean, their geometries will be different. So they are not identical. They are not identical. They are not identical, right? What about this question? Calculate EMF of the following cell at 25 degrees centigrade. If the value of E naught cell is given, so first of all, this is your anode and this is your cathode. So what is the reaction taking place at anode? At anode, oxidation takes place. M solid is getting converted into M di positive, whose concentration is how much? 0.01 molar plus 2 electrons. Similarly, at cathode reduction takes place. Reduction means gain of electrons. So M di positive with a concentration of 10 raised power minus 4 molar. 10 raised power minus 4 molar would be gaining 2 electrons and getting converted into M solid. Perfect. So electrons are balanced in both. You can directly add them up. When you add them up, this M solid cancels out. So you get M di positive, whose concentration is 10 raised power minus 4. It gives M di positive, whose concentration is 10 raised power minus 2. Can you get the QC value here? QC is 10 raised power minus 2 divided by 10 raised power minus 4. The value comes out to be 10 raised power 2. What was the N value? N value was 2. Write the Nernst equation. E cell is equal to E naught cell. E naught cell is 4 minus 0.06 divided by N log of QC. QC is 10 raised power 2. Log of 10 raised power 2 is 2 log 10. So 2 comes to the front. Log 10 is 1. So this is 2. 2 and 2 gets cancelled. 4 minus 0.06 comes out to be 3.94 volts. Is there any option like this? 3.94 volts? Yes. By just using the Nernst equation, you just solve the question. Okay? I hope this is also clear to every one of you. Perfect, guys. What about the answer of this question? You are given with NaOH. Concentration of NaOH is given. NaOH is first of all a strong base. It would have got dissociated as Na positive plus OH negative. So in the beginning, you are keeping the concentration of NaOH as 10 raised power minus 3 molar. This is 0, this is 0. Now this is 0. This is 10 raised power minus 3. This is 10 raised power minus 3. So concentration of OH negative, I got to know as 10 raised power minus 3. So I can easily calculate POH. POH means minus log of 10 raised power minus 3. It means 3. If you got POH as 3, that means pH has to be equal to 14 minus POH. The value has to be 11. So 11 is the pH of the final solution. Simple question, right? But a lot of students will be writing the answer as 3 also, if there is option 3, right? In a hurry. So be careful with all of this. Be careful with all of this. Be careful with all of this. Oh, this is the question whose answer is already given. Which of the following ion exhibits DD transition? Where do you see DD transition? Wherever there will be unpaired electrons, DD transitions will be there. This is chromium plus 6, so no unpaired electron. Chromium plus 6, no unpaired electron. Manganese plus 7, no unpaired electron. Manganese plus 6, 1 unpaired electron. So here you will find DD transitions. Wherever there are unpaired electrons, there will be DD transitions, right? So it has to be option C. It has to be option C. Identify the wrongly matched pair. NH3 is AB3L1 type. So trigonal pyramidal, correct. PCl5, AB5L0 type. AB5L0 means trigonal bipyramidal. But here they have mentioned trigonal planar. So this one is incorrectly matched. This one is incorrectly matched. Okay. Perfectly done. All right. You are given the reaction A gives B. You are given the reaction A gives B. Enthalpy of the reaction is negative, exothermic. And for exothermic processes, you know, energy of products is less than energy of reactants. Energy of products has to be less than that of energy of reactant. So this is the answer. Energy of product has to be less than that of energy of reactant. So the graph has to go down basically. So it has to be this. If it was endothermic, for endothermic, the graph would have been this. For endothermic, the graph would have been this. Or this. Or this. Right? Okay. What about this one? The reaction X gives Y. Reaction X gives Y. Is it exothermic reaction? Activation energy for the conversion of X into Y. So EAF, activation energy of forward reaction, is equal to 150 kilojoules. Enthalpy delta H is equal to 135 kilojoules. But since the reaction is exothermic, so delta H has to be negative. What am I supposed to calculate? I'm supposed to calculate EAB. Since you know your delta H is nothing, that is EAF minus EAB. EAF minus EAB. So this is minus 135 is equal to EAF is 150 minus EAB. So I can say EAB has to be equal to 285 kilojoules. So EAB is equal to 285 kilojoules. This again a good question from which is frequently asked basically. And my dear students, one last question. I would want its answer in the comment section of this particular video. Okay? I would want its answer in the comment section of this particular video. So with this, I'm done with the session. I hope you enjoyed it. My dear students, please and please check this session again, because I believe the questions directly, indirectly will be from this particular session only. Okay? Perfect. So with this, I'm taking a leave. I think this was my last live academic session with all of you. Okay? With the NEET 2025 aspirants, I mean. Yeah? This was my last academic session with the NEET 2025 aspirants. I feel so. Okay? It was an amazing journey, my dear students, with all of you by taking long marathons, right? Long marathons we have taken on this particular channel. Now, I'm wishing you all the luck for your examination. Do well, okay? Do well, do amazing. Our prayers, our good wishes will be always with you. And we hope you guys kill this particular examination this time, okay? You guys enter the examination hall like the boss and leave the examination hall like the boss. That's what we'll be praying for. That's what surely we'll be praying for. Yeah? Whatever we could do from our side, we have done that. You know it. Okay? Whatever we could do, we have done that. Now it's going to be your turn to make yourself proud, your parents proud, and to make us proud, guys. Okay? But again, I'm telling you, do not think about the consequences right now. Do not think about the results. Just focus on these 3 days properly. Okay? Just try to revise as much as possible. All your formula sheets, all your, organic reaction sheets, all your short notes. Do not study anything new at this point of time. Do not do that at all. Do not study anything new, my dear students. Okay? Yes, I'll be coming up with one motivational video for all of you. Don't worry. That will motivate you like anything. Okay? But not today, after 2 days or 1 day. Chalo, I'm taking a leave. God bless you all. Okay? Do let me know in the comment section how you're feeling after this last session with me. Okay? I'll be waiting for all your comments in the comment section of this particular video. Take care, guys. God bless you all.